Here we have a SAT math problem. Okay, let's go to the question. The scatter plot shows the relationship between two variables x and y for data set P. A line of best fit is shown. Data set Q is created by multiplying the y coordinate of each data point from data set P by 4.3. The equation for the line of best fit for data set Q can be written in the form Q of x equals to a positive bx. What is the value of a negative b? Okay, in the given graph, I have scatter plot and line of best fit for data set P. And if I want to get a data set Q, what I have to do is at each point of the data set P, I have to multiply the y coordinate by 4.3. Okay, from the given line of best fit for data set P, let me choose 2 points. Okay, now we have to choose 2 points so that both the x coordinate and y coordinates are integers, so that the calculation process will be easier. Okay, now let me take the point over here. Here the x coordinate is 3 and y coordinate is 2. And let me get a point over here. Here the x coordinate is 1 and y coordinate is 7. Okay, here I have taken 2 points from the line of best fit for data set P, and in both the points the x coordinates and y coordinates are integers. Okay, now let me write the stuff over here. Okay, from the line of best fit for data set P, we have 2 points, 1 comma 7 and other one is 3 comma 2. Okay, from these 2 points, if I want to get the corresponding points for data set Q, what I have is I have to multiply the y coordinate over here and y coordinate over here by 4.3 according to the instruction we have over here. Okay, 1 comma, let me multiply this 7 by 4.3, then I'm getting 30.1. And here 3 comma, let me multiply this y coordinate by 4.3, then I'm getting 8.6. Okay, here I got 2 points for the data set Q. Okay, our aim is to get the equation for the line of best fit for data set Q. Once I get the equation for the line of best fit for data set Q, it can be compared with the equation we have over here. When I do so, I'll be able to get the values of the constants a and b. So from the values of a and b, I'll be able to get the value of this expression a negative b. Okay, since we are trying to find the line of best fit, it will be a linear equation, and we can get the equation of line of best fit for data set Q in slope iterator form. For that, first we have to get the slope of line. Let me consider this is point x1, y1, and this is point x2, comma y2. And when we have 2 points on the line, there is a formula to get the slope of a line. That is m equals to y2 negative y1 divided by x2 negative x1. Okay, here the value of y2 is 8.6 and the value of y1 is 30.1 divided by, and the value of x2 is 3, the value of x1 is 1. Okay, now let me do the subtraction. That is 8.6 negative 30.1. Then I am getting negative 21.5 in numerator. In denominator, 3 negative 1 is 2. Okay, now let me divide negative 21.5 by 2. When I do so, I am getting negative 10.75. Okay, here I got the slope of the line of best fit for the data set Q. Okay, now let me write the equation of line of best fit for data set Q in slope intercept form. That is y equals to mx positive b. Okay, here m represents the slope. Already we got the value of m, that is negative 10.75. Let me plug in this value for m over here. Then I'm getting y equals to negative 10.75 x positive b. Okay, here we have to find the value of b, which represents the y coordinate at the y-intercept. Okay, for that we have to use one of these 2 points. That is, we have to plug in one of these 2 points into this equation to get the value of b. Okay, now let me use a second point. That is, I have to plug in this x coordinate 3 for x over here and y coordinate 8.6 for y over here. Okay, let me do it. Then 8.6 equals to negative 10.75 times 3 positive b. 8.6 equals to, okay, let me multiply negative 10.75 by 3. When I do so, I am getting negative 32.25 positive b. Okay, now let me add 32.25 to both sides of the equation. Let me do it. 32.25. When I do so, this negative value, positive value will cancel out. Okay, now let me add 32.25 and 8.6. When I do so, I'm getting 40.85 on the left side. Okay, let me write over here equals to b. Okay, here I got the value of b. Okay, now what we can do is we can plug in this value for b over here in this equation. Okay, now let me take the equation over here. Then we get y equals to negative 10.75x positive 40.85. Okay, here I got the equation of line of best fit for data set Q over here. Already we have such an equation over here, that is q of x equal to a positive bx. Okay, now let me write this equation exactly in this form, and also let me replace this y by q of x, and here in this equation we have constant at first and then x term. Okay, now let me write this constant 40.85 at first, then write the x term, that is negative 10.75 x. Now the equation we got over here is exactly in this form. When I compare this one and this one, at the place of a, there is a constant term. Over here is 40.85, and here the coefficient of x is b. Here the coefficient of x is a negative 10.75. So when we compare this one and this one, we get a equals to 40.85 and b equals to negative 10.75. Our aim is to get the value of a negative b. That is a negative b equals to, for a we can plug in 40.85, negative, for b we have to plug in negative 10.75. Okay, 40.85 negative times negative is positive 10.75. Okay, now let me add these two values. So that is 40.85 positive 10.75. When I add them, I am getting 51.6. Okay, here I got the value of the expression a negative b, that is 51.6.